Hello everyone, welcome back to Physics Mastery, Lecture 6 in Mission 600. So far we have covered about 5 lectures. In that nearly 110 questions I have completed PYQ. This is Lecture 6. In this I am going to discuss about system of particles. So I request you to be a little more engaging because that will give motivation to us. So I took a while to get with this Lecture 6 because I didn't get the critical number in the previous video. Anyway, now that we have got that critical number, I'm ready with this lecture. Okay, let's move on with the next slide here. Solve questions. Let me read the problem. A nucleus disintegrates into two nuclear parts in such a way that the ratio of their nuclear sizes are in the ratio 1:2 power 1 by 3. So that is the radius ratio. We got this R1 by R2 equals to 1 by 2 power 1 by 3. This is one they had given information. And the nucleus are disintegrating. Let's say you have a bigger nucleus like this. Once it breaks up into two smaller pieces, right? So initially at rest, that means momentum has to be 0. And then when it separates, they would move in opposite direction with speeds v1 and v2, masses, let's say m1 and m2. So that net momentum has to be 0. Momentum is 0. That means m1 into v1 in one direction should balance m2 into v2 in opposite direction. And in a nucleus, mass is proportional to mass number. A1 into v1 equals to a2 into v2. So that's the second equation. We have it. All right. Now what are they asking? Their respective speeds they're asking. So let's write v1 by v2 is coming out to be equal to a2 by a1. a2 by a1 we have it. Now, A2 by A1 I have to calculate, but that they have given the radii. How do I find radii ratio to mass ratio? We have this formula, the density of nucleus is constant. So, volume, right? Mass is proportional to volume. All right, because density is constant and that is proportional to radius power 3. And so, mass number A2 by A1 will become R2 by R1 whole power 3, which is going to be just the reverse it and cube it, you will get 2. So if I substitute it here, this is going to be 2 by 1. That means V1 equal to 2 times, whereas V2 is 1. So N is to 1 would become 2 is to 1. So N equal to 2. That's the answer to this. So conservation of linear momentum and other relation is A proportional to R cube from nucleus. Those are the two ideas we are using here. Next question. A ball of mass 200 gram rests on a vertical post of height 20 meter. Okay. The ball is standing. A bullet of mass 10 gram is traveling in a horizontal direction, hits the center of the ball. Let's say this 10 grams, if I take M, right? This 200 gram becomes 20 M. So I don't need actually the mass, only the ratio I require. M and 20 M we take. So this bullet hits that ball. After the collision, both travel independently. They go separately. The ball hits the ground at a distance 30 meters and the bullet at a distance 120 meters. Let's say this is a tower we have. And from the tower, bullet goes and falls somewhere here at a distance how much? 120 meters after the hit. Whereas the ball would fall at a distance 30 meters here. This is 30 meters here. So 30 meters and 120 meters. Then the question is, what is the initial velocity of the bullet before the firing? Let's say bullet was having a mass m and coming with u velocity. This u we have to calculate. So the ball would have 20 m and the bullet is got m mass here. Now that we have got horizontal displacement, we'll try to connect. This is kinematics question connected to collision. First, let us do the backward calculations. So if it is covering 30 meters and 120 meters in horizontal direction, what is the horizontal displacement? That would be only horizontal velocity into time of flight. And time of flight will depend only on vertical motion. And vertically, they don't have any initial velocity. They fall just because of gravity. So this is going to be Vx into root 2h by g. That is going to be the displacement there. So from there, I can calculate Vx will be equal to displacement by root over 2h by g. All right. Now suppose I use that. Let's say it is projected with a horizontal velocity v1 bullet and a ball, and the bullet is coming with velocity v2. Let us say v1 will be equal to 30 meters is the horizontal displacement, and divided by root 2h by g. Let's calculate that. Root 2 into h is 20, g if I take 10, that is given. So 2 seconds is root 2h by g. If I substitute there, you will get 15 meter per second. That is the velocity of the ball after the hit. And velocity of the bullet also let us calculate just after the hit. That will be v2 equals to displacement is 120 by the same time of flight. Time of flight is independent of horizontal velocity. It depends only on vertical motion. So it will still have the same time, 2 seconds. So this is going to be 60 meter per second. Now we need to find the velocity of the bullet before collision. For that we use conservation of linear momentum. So m into u has to be equals to m into v2. v2 is 60 plus 20m into this velocity v1. How much is that? 15. So if I substitute there, m gets cancelled out anyway. Then you will see u equals to 60 plus 300. That means 360 meter per second. That is going to be the velocity before collision. So what are the ideas we've used? Projectile motion horizontally, that is one important. Vertical motion will decide time of flight. Horizontal motion will be constant, uniform motion, constant velocity you have, because there is no horizontal acceleration. And then before collision, momentum has to be conserved just after collision, only in horizontal direction. That's the idea we have it. So let's go to the next problem. As per the given figure, a small ball P slides down a quadrant of a circle. So we have a circle here, quadrant of a circle is there. It is going to go in a circular path, sliding down. Okay. Hits the other ball Q of equal mass. Okay. Equal mass is one important thing, which is initial at rest. So this is at rest. Okay. Very good. Neglecting the effect of friction. So friction you can avoid, meaning you can use conservation of energy. Whatever is the loss in gravitational potential energy gets converted into kinetic energy. Okay. Now, what are they asking? The velocity of the ball Q after collision would be. You see here, whenever you have head-on elastic collision, head-on and elastic collision, head-on and elastic collision, if you have, then what happens? And that too when they have equal masses, velocities get exchanged. So this is one important idea, very, very important. Many times that has been tested in all kinds of competitive examination. So P comes with, let's say, V velocity, Q was stationary. When it hits, P comes to rest, Q will go with the same velocity. So that velocity is what we want to calculate. Otherwise, you can simply conserve from beginning to final. Even though there is a collision, collision is elastic, there is no loss of energy. So initially you had gravitational potential energy, mgh, and that should get converted into kinetic energy. That's all. The collision does not change the velocity. It's just that it gets transmitted to the other particle. P comes to rest, Q goes with the same velocity. Okay, so we have V getting cancelled out. V equal to root 2GH. You can substitute the values now. 2 into G, I'll take 10. And H, how much? H is basically radius, which is 20 centimeter, meaning 0.2 meter. You would get 2 meter per second. So very simple problem, right? Conservation of energy, even though there is a collision, because the collision is elastic. All right, let's go on further. A machine gun of mass 10 kg fires 20 gram bullets. Mass of each bullet is 20 gram. Okay, let's call it as M. At the rate of 180 bullets per second. Rate of firing. So rate of firing. Okay, let's call it as N dot, which is 180 per minute. 180 per minute can be written as 180 by 60 per second. That is going to be 3 bullets per second. Every second, 3 bullets are being hit very fast. Okay. And each bullet is going with a speed 100 meter per second. All right. Now they're asking the recoil acceleration. First of all, why would the gun recoil? Why should it recoil? Because of the back force. Why is it getting back force? Because bullets are getting momentum in forward direction. Action to reaction, gun gets a momentum in opposite direction. So we can simply calculate the force acting on the bullets there. All right, average force. Let's calculate the average force acting on the bullets. And that will be equal to n dot, number of bullets fired per second, into momentum transferred, m into v final minus u initial. So that is going to be n dot is 3. Mass of each bullet is 20 gram, 20 into 10 power minus 3. Into finally, once it is fired, it will have 100 meter per second velocity. Before firing, it is at rest. Inside the gun, it was stationary. So this is the force that would be acting. You see these 3 zeros gets cancelled off with this. So you have 6 Newton force. On an average, the gun is firing with 6 Newton force on the bullets. Action to reaction, on the gun there is 6 Newton force in backward. So this recoil acceleration equal to same amount of force, 6 Newton in opposite direction, divided by mass of the gun is 10 kg. 10 kg. So that is going to be 0.6 meter per second squared. Recoil acceleration is 0.6 meter per second squared. That's the answer for us. Let's move on. An average force of 120 Newton is applied on the machine gun. Again, machine gun related problem. So this seems to be a very important model. Even in KTG also this idea is used when bullets, instead of bullets, you have molecules hitting it. So KTG is also developed out of this particular idea. You have to go through this particular model. Okay. Average force of 125 Newton is applied on a machine gun, firing bullet each of mass 10 gram and at a speed of 250 meter per second to keep it in position. The number of bullets fired per second by the machine gun is. So you need to apply 125 Newton. Otherwise, what happens? It is recoiling. That means the force exerted by the gun on the person is also 125 Newton. Why is it exerting? Because the bullets are pushing it back. So now the force has to be same amount there. The force exerted on the bullets on an average is 125 Newton. 125 Newton. And that has to be equal to n dot into mass of each bullet into v minus u. All right. Now, what are they asking? Number of bullets fired. They are asking only n dot. N dot equal to 125 Newton divided by what is mass of each bullet 10 gram, meaning 10 power minus 2 kg. That is mass of each bullet. Into velocity is 250 meter per second. So now simplification, you see 10 power minus 2 in the denominator becomes 100 when it goes to numerator. And then this 125, 2 times it goes up. So you have 50 per second. That's pretty fast. 50 bullets per second, a real machine gun here. So firing at a speed of 250 meter per second. And that requires 125 Newton force. 125 Newton force is quite a lot. It's like 12.5 kg dumbbell being lifted up. All right, it's a good amount of force there. That's why they generally keep it on the shoulder to hold it, right? That recoiling part. Anyway, let's move on with the next question. A ball is dropped from a height of 20 meter. The coefficient of restitution for the collision between the ball and the floor is 0.5. After hitting the floor, the ball rebounds to the height of. So this is very important model, Newton's law of restitution, we call it as. So now let us say it is falling down from a height h naught. That means at the just before hitting its velocity, let's say u, that will be root over 2g h naught. Then after collision, it is going to rebounce back with the velocity v, and let's say it goes to a height h. That's the maximum height it can go to. So that means v has to be equal to root 2gh. Okay. All right. Now coefficient of restitution is speed of separation after collision divided by speed of approach before collision. That will be root over 2gh divided by root over 2gh naught. So 2g gets cancelled out and you square it. You will get h equal to h naught into e square is a very important formula. You should know this result. It's like a formula. H equal to h naught into e square. Now you can substitute h naught is 20. E is 1 by 2. 1 by 2 square, you will get you 5 meters. Yeah, 5 meters is the answer. This is called Newton's law of restitution. Okay, very important model and simple. Okay, all right, then let's go to the next problem. A body of mass capital M explodes into 3 pieces. So capital M at rest initially. Okay, initial momentum 0. That means momentum will be 0 during collision, even just after collision. And it breaks up into 3 pieces and the ratio of the masses are given. 1:1:2, meaning you can take M, M and 2M. So total capital M can be assumed to be 4 small m. That is all right. Two smaller pieces, meaning M and M, they go perpendicular to each other. Let's say one goes along x-axis with 30 meter per second, the other goes with 40 meter per second in y-axis. And they're asking you to find the velocity of the third piece there. Okay. So now that momentum of the system is 0, all right. That means velocity of center of mass has to be 0. Velocity of center of mass has to be 0. And so m into v1. v1 is how much? 30 I cap, let's take, assuming it to be going along x-axis. Then m2, that is also m, going along y-axis, 40 j cap, mutually perpendicular, I'm taking x and y. Then the last one is 3m mass, and let's say it is having v3 velocity, so total momentum has to be 0. Okay. So m gets cancelled. All right. Then v3 will be equal. I think this is 2m, no? 2m. Okay. So v3 will be equal to minus of 30 I cap plus 40 j cap whole divided by 2. That is v3. Now we just take the magnitude of it, because the coordinates we only took. They did not mention it. So the magnitude would be half of root over 30 square plus 40 square. And it's a triplet, a very famous triplet. You will get 50 upon 2, which is 25 meter per second. That is going to be the velocity of the third part. So conservation of a linear momentum, just that it is 3-particle system we have it. Okay. Next, a bag of sand of mass 9.8 kg suspended by a rope of bullet of 200 gram. 200 gram meaning you can take it as 0.2 kg SI traveling with the speed of 10 meter per second gets embedded. Embedded meaning gets stuck into it. Then loss of kinetic energy. It's a simple formula based. See, kinetic energy of a 2-particle system, if you have, you can write that into 2 parts. One is half of m star into v relative square. We call it as internal kinetic energy, otherwise kinetic energy with respect to center of mass, where m star is called reduced mass, m1, m2 by m1 plus m2. All right. And then we have other part of the kinetic energy, which is going to be half of m1 plus m2 into vcm square. This is called kinetic energy of center of mass, or otherwise orbital kinetic energy or external kinetic energy. So when you take the sandbag and the bullet together as a system, the collision force is internal force. Internal force cannot change the kinetic energy of center of mass. Center of mass velocity doesn't change. Only the internal kinetic energy will get affected. And so here Ke loss, we are supposed to know this, we are supposed to remember it. That will be equal to half m star into u relative square, initial internal kinetic energy minus final internal kinetic energy. This is what we have. And here it gets embedded, meaning finally there is no relative velocity. They go together with common velocity. And m star, we can calculate. What is m star? 9.8 into 0.2 divided by 9.8 plus 0.2 is going to be 10 there. So if I write it as 2 by 10, it becomes 19.6 divided by 100 kg. That is going to be m star. And what is u relative? U relative is simply u only, because bag was stationary, only bullet was moving, and that is given as 10 meter per second. All right. So now if I substitute everything here, that will be half of m star is 19.6 by 100 kg into u. U is how much? 10. 10 squared. So 10 squared and 100 will cancel out. 19.6 by 2 will become 9.8 Newton. That is going to be 9.8 joule, because it's a energy we are looking at. No? So 9.8 joule, that is a loss of energy that will have it. Okay, that's the point here. You need to remember this particular relation. Loss in kinetic energy equal to half of m star into u relative square minus v relative square. This is loss in internal kinetic energy, not the kinetic energy associated with center of mass. Okay, next. 2 billiard balls of mass 0.05 kg, each moving in opposite direction with 10 meter per second, collide and rebound with the same speed. Collide and go on. Okay. If the time duration of the contact is 0.005 seconds, then what is the force exerted on the ball due to each other? So it's basically average force we are talking about. Average force is what? Change in momentum per unit time. All right. Now the particle, each one is coming with a speed v. After collision, it is going to go back with the same speed v. All right. So we have v minus of minus v divided by delta t. So this is going to be 2mv divided by delta t. Now we can substitute the values twice out. Mass is how much? 0.05. That is 5 into 10 power minus 2. Into velocity is how much? 10 meter per second. And divided by delta t, 0.005, which is 5 into 10 power minus 3. So 5 gets cancelled out. This 10 power minus 2 cancelled out with 10 power minus 2, and you are left with 10 power minus 1. So goes up, it becomes 10 into 10 into 2 will give you 200 Newton. That's a huge amount of force for a small object that we are dealing with. A good amount of force there. Impulsive force, we can call it as. All right. Next, three identical spheres, each of mass capital M, are placed at the corners of a right-angled triangle with mutually perpendicular sides equal to 3 meters each. 3 and 3, and then you have hypotenuse there. Taking point of intersection of mutually perpendicular sides as origin, the magnitude of position vector of the center of mass of the system will be. Okay, it's we need to draw the coordinate system first. Okay, this is, let's take this as x-axis, y-axis. This is origin 0, 0. Now we have three objects here, and let me take those objects color as probably this color. Let me take. So we have one object here and one object here, another object here. They gave that this is 3 meter, 3 meter, 3 meter. Okay. Let's say this is object 1, object 2, object 3. So now if I want to calculate the position vector of the coordinate system RCM, that will be equal to M1 into R1 bar plus M2 into R2 bar plus M3 into R3 bar whole divided by M1 plus M2 plus M3. This is a general formula. Okay. Now the masses are equal. Each one is capital M. So denominator becomes 3M. Okay. M1 into the position vector of this particle is 0 bar because it is at origin directly, plus M into, let's take this as R2. It is only along x-axis, so it will have the position vector 3i cap plus capital M into, the other one has got only y direction coordinate here, 0, j. So this is going to be 3j cap. Okay, 0, 3 you have it. Now if you cancel out M here, what do I get? 3 also would cancel out. You will get I cap plus j cap. I cap plus j cap. And if they ask you to find the magnitude of it, right? Magnitude of RCM, if you calculate, that's going to be root over 1 square plus 1 square, which is root 2. So that means x equal to 2. Root x they ask now. So x is going to be 2. That's the idea we have it. All right. Next problem. The momentum of a body is increased by 50%, and the percentage increase in kinetic energy of the body. It's actually a very simple problem. Probably they can ask this in MSET or NEET examination also, but still sometimes student may do a bit of small mistake. That's why I just do it. So let's say initial momentum is T, for example. Then what is the final momentum you have? It is increased by 50%. That means final momentum will be 1.5 P. This is one relation. 50% increase meaning it has become 0.5 times of the initial value increased there. Okay. Now percentage increase in kinetic energy they are asking. What is the kinetic energy formula? Kinetic energy is P square by 2m. Basically proportional to P square because we are assuming the body. They said body, no? Mass is not going to change for a body unless specifically mentioned. So then percentage change they are asking. KE final minus KE initial divided by KE initial into 100 they are asking. So that would be P final square minus P initial square divided by P initial square times 100. That's what we have here. P final square 1.5 square. 1.5 square is 2.25 into P square minus P square divided by P square. So P square would cancel out. 2.25 minus 1 will be 1.2 into 100 we have, no? 1.25 into 100, it becomes 125%. 125% is the increase there, right? So final value is 125% more than the initial value. That's what we have here. All right. Then let's go on to the next problem. A bullet of mass 0.1 kg moving horizontal with a speed of 400 meter per second hits a wooden block of mass 3.9 kg kept on a horizontal rough surface. Okay, the bullet gets embedded into the block and moves 20 meters before coming to rest. The coefficient of friction between the block and the surface will be okay. So first let us calculate the velocity of the block just after the hit. Okay, velocity of the block just after the hit. You have 0.1 into 400 and that is equal to 3.9 plus 0.1 because they go together afterwards times let's say some V naught for example just after the hit. This is just after collision. So students may have little bit of doubt or maybe I'll raise a doubt here. Why are we not considering loss in energy during collision because of friction here? How can we conserve momentum even though there is friction there? All right. Actually, we can conserve. We can conserve it approximately. I want you to think why we can do it. So from there, we can calculate V naught. V naught will be, this is 40 by 4. You will get 10 meter per second. So it has got 10 meter per second velocity. Now the block is there, 4 kg block, totally 3.9 plus 1, having a velocity 10 meter per second. Now it is sliding on the surface. When it is sliding on the surface, it will be experiencing an acceleration, and that is going to be mu g because of kinetic friction. So now what is it saying? It is going to travel 20 meters. It will come to rest after traveling 20 meters. 20 meters it has traveled to come to rest. Then he is asking you to find the mu there. Okay. So now let us write kinematic equation because acceleration is constant. We can use kinematic equations. V square finally when it comes to rest minus u square 10 square must be equal to 2 into acceleration is minus mu g. Why minus mu g? Because it is opposite to velocity into displacement is 20. All right. Now you see here g is 10 and this 0 will cancel out. Minus minus will cancel out. You will see that it is going to be 1 equal to 4 mu or mu equal to 1 by 4. Mu equal to 1 by 4 meaning 0.25. 0.25 somehow I don't know, but that mains exam questions coming out of that value only most of the time 0.25. Many questions are like that. Okay, right. Assertion. Three identical spheres of same mass undergo one-dimensional collision as shown in figure, one-dimensional motion they are going, and then they have initial velocities like that, 5 unit, 2 unit, 4 unit, like that. Now, if you wait sufficiently long for elastic collision to happen between them, then finally VA will be equal to 2 meter per second, VB will be 4 meter per second, VC equal to 5 meter per second is what they are saying. So let us try to understand the reason they give. In an elastic collision between two identical masses, two objects exchange their velocity. So reason is correct only. That is a very familiar statement. But now assertion whether it is correct or wrong, we need to see that. First of all, you see between B and C, C is the leader and B is the follower. And you see C is going faster. When C goes faster than B, separation between B and C increases. That means there won't be any collision between them. But look at A and B. B is the leader and A is the follower, and A is coming faster. So when the follower approaches faster, the separation decreases, and so eventually they'll have collision. Meaning first collision happens between A and B. So once the collision happens between A and B, they exchange their velocities. So what happens? A will have a velocity 2 meter per second, and B would get a velocity 5 meter per second. And C would be continuously going with the same velocity 4 meter per second forward. Okay, now again, no, look at it. Between these two, there is no possibility of collision again, all right, until the velocities change because this guy is faster. One who is going away is having faster velocity. Now, between these two, if you see, B is the follower, C is the leader, and B is going faster. Now, B starts approaching C, so the separation will decrease now. Earlier, it was increasing, but now it starts decreasing. Eventually, there will be collision between these two also. And then what happens? They get exchange velocities. So you will have A having a velocity 2 meter per second, right? B will have velocity exchange 4 meter per second going in this same direction. And C gets that velocity 5 meter per second. And after that, you see C will continue to go and B is going, A is going. You see every time leader is having more velocity than the follower, so there is not going to be any more collision. Totally two collisions happen there. So this is the final situation you have, and that's what they are saying. V equal to 2 meter per second, B equal to 4 meter, and then VC is equal to 5 meter per second. I think so. Assertion is correct, reason is also correct, and explanation is also good. Okay, so that's the answer we have. It's a good question. We need to have a little more analysis here. Okay, right. Let's move on to the next problem. A uniform rod, which I assume to be thin uniform rod of length 5L is bent at right angle, keeping one side is 2L and other side is 3L, as shown in the figure. The position of center of mass of the system we need to identify. All right, so what do? We'll cut that into two parts. So this is one part we have. Okay, let me take another color for the pen. So what color should I take? Maybe this color I'll take, or this color I'll take. So for this part, okay, you will have center of mass over here in the middle, call it as C1. And this part, right? For this also you have center of mass in the middle, which is C2. I'm neglecting the thickness here. So now if I ask you, what are the coordinates of center of mass of each? C1, if I ask, what will be the center of mass coordinates? It is in the middle. That means x coordinate is L and y coordinate 0 because it's on x axis. C2, if you look at it, it will be x coordinate is 0, y coordinate would be 3L by 2. That's what you have. And masses also, if you look at, let's say if you take this as 2m mass, this has to be 3m mass because it's a uniform rod, right? Length ratio is mass ratio. Now we can write a xcm here. xcm, that will be equal to 2m into L plus 3m into 0 divided by 5m. So 5 gets m gets cancelled out, you will get 2 by 5L. That's going to be the xcm. Same way YCM, 2m into 0 plus 3m into 3L by 2 divided by 5m. So mass gets cancelled out, you will get 9 by 10. 9 by 10L. Those are the going to be the coordinates there. So the coordinates will be on this line. You just join these two together. Somewhere here you're going to have center of mass on the line joining. But anyway, those are the coordinates you have. It's a very simple, straightforward. Okay, then let's go on. Yeah, this is one important model, cutting up the material. A circular hole of radius a by 2, this is circle, is cut out of a circular disc of radius a as shown in the figure. The centroid of the remaining circular portion with respect to the point O would be. All right. So now if I take a full disc, all right, full disc, let us call it as a capital M, mass capital M. What will be the coordinates of that? So that is going to be here, no? So that's going to be a comma 0. Okay. Then the removed part, right? Removed part, let's call it as minus m because it's negative mass. Removed is like negative mass you have. Removed part will have coordinate there. This one, right? This is a by 2. A plus a by 2, it is going to be 3a by 2, comma 0. So only x coordinate we need to focus on. Y coordinate of center of mass will be 0 only. Now they're asking you to find xcm. xcm will be equal to capital M into a plus minus small m into 3a by 2 divided by capital M plus minus small m. So this is called, in some books they write it as negative mass concept, whatever it is. In reality, remember, there is nothing like negative mass, but it works very well. Taking the whole can be visualized as plus m and minus m plus m is combined with the full disk to make it a bigger disk. So that is very nice idea, but very useful method, right? Negative mass idea, only mathematical, physically has no physical significance there. So this is what I'm going to get there. And you know that it is uniform circular plates. That means mass will be proportional to area. This can also be written as capital A into small a minus what is that area. So when radius is half, right, area becomes a by 4. All right, a by 4 into 3a by 2 divided by a minus a by 4. I hope you understood. And radius is proportional, area proportional radius square. Radius half meaning area becomes 1/4 there. So a gets cancelled. Then what is that you are having here? A minus 3a by 8 divided by 3a by 4. So 8 minus 3, 5, 5a by 8, 5 by 8 times of a into 4 by, there's no a over here, into 4 by 3. So 4 2s it gets cancelled. You will get 5 by 6 times away. That is going to be the coordinates of the remaining part of center of mass there. So you can use this formula m1 x1 plus m2 x2 by m1 plus m2 only. Just that removed part you take it as negative mass and solve it. You will get very nicely. But again, once again I tell you, there is no physical meaning of negative mass, but mathematically it works pretty well to solve this particular problem. Okay then. Same idea. Let's go with one more question. Now I am considering a spherical body, 3D object, centered at O. So center of that is having radius 1 centimeter is cut out of a uniform sphere of radius capital R, centered at C. Center of mass of the remaining part of the sphere is G, that is on the surface of the cavity capital R, can be determined by the equation. Okay, right. So now we need to calculate radius here. Let me take another color which can be clearly visible on that part. So probably I'll take this color. Let me take this as origin. Okay, and this is origin. I will take this as x-axis. This is x-axis. Okay. So if this is origin, then this will be 1 comma 0 because radius is 1 centimeter. And the totally how much? This is totally, this is going to be 2, no? Diameter. That is going to be diameter. And this distance is r, radius of the sphere. So this is 2 and this is 2 r. Then I can calculate this distance also. That is going to be how much? 2 minus r. So look at it once again. The total distance is diameter, which is 2. And from the center of the bigger sphere to the edge, it is going to be capital R. The gap is going to be 2 minus r. Now, if I ask you the coordinates of the remaining part, if I consider, let me go back to the lighter colors again. Remaining part, if I go to, it has got the coordinates 0, comma 0. I'm taking G as origin. Okay. Then the full sphere, right? Full sphere. All right. Where is the coordinate of it? C, no? That is going to have 2 minus r. 2 minus r is the x coordinate and y coordinate is 0. Then removed part. Removed part is at a distance of 1 centimeter. That is going to have coordinate 1, comma 0 there. All right. Let's say the full sphere mass is capital M. The removed sphere mass is minus m, negative mass idea. Then we want to find xcm which is 0 equal to capital M into 2 minus r plus minus small m into 1 whole divided by capital M plus minus small m. But xcm 0 meaning numerator is 0. All right. So you can take this off there. Then what do I get? Capital M into 2 minus r minus m equals to 0. That's what I have. But what is capital M? Capital M is proportional to total volume. Small m is proportional to volume of the cavity. So mass proportional to volume. That's what I'm going to use here. Capital M is proportional to 4 by 3 pi r cube. 4 by 3 pi r cube into 2 minus r minus small m. Small m is proportional to volume of the cavity there. That is 4 by 3 pi into 1 cube. That is equal to 0. So 4 by 3 pi anyway cancels out. And so we have this relation r cube into 2 minus r minus 1 equal to 0. All right. That means final answer is going to be r cube into 2 minus r equal to 1. That is going to be the expression there. It's a very simple idea. Again, mathematical concept of negative mass we are going to use. A very useful, very powerful result. Just like that you will get it. You don't have to face any difficulty here. If it is a 3D object, mass proportional to volume. If it is a 2D object, mass proportional to area. If it's a linear object and that too uniform, of course, mass proportional to length, we can take it. So that's a very important result. Okay, next, center of mass formulae. Some formulae I have taken. A disk of mass capital with uniform surface mass density sigma is shown in the figure. Center of mass of the quarter of the disk, only the shaded part of the disk they are asking, and the coordinate they had given it. It is direct formula. If you have a circular arc, right? Circular arc, then your distance of center of mass from the center, let's call it as r naught, that would be how much? R into sine theta by 2 by theta by 2. All right, here theta equal to pi by 2, quarter circle. No? So how much do I get? R into sine pi by 4 by pi by 4. That is going to be 4 by pi times of R into sine pi by 4 is 1 by root 2. So you have 4 by root 2 pi into R. Otherwise 2 root 2 pi, 2 root 2 R by pi. That is going to be the distance of center of mass if it is a circular arc. That I remember. The moment I know circular mass center of mass formula, immediately I can calculate disk formula. For the disk, what happens is, whatever is the distance you got for circular arc, you multiply with 2 by 3. 2/3 you will have it. Okay. There is a simple idea also, concept related to that. We'll discuss it when it requires. But remember it, 2/3 of whatever you got for a circular arc, that is going to be 2 root 2 R by pi. That is going to be 4 root 2 by 3 pi into R. That is going to be the distance of center of mass from the center. So now if I show it, distance meaning from the center, this one is R0. Then they're asking what? X coordinate and Y coordinate. You're going to drop a perpendicular, it will be R0 by root 2 and R0 by root 2. Alright. So if I ask the X coordinate and Y coordinate, divide by root 2. That means XCM will be equal to 4 by 3 pi into R and YCM equal to 4 by 3 pi into R. So X by 3 pi into R and X by 3 pi into R. That means X is equal to 4 here. For a circular arc, this is a formula. When you go for a circular disk, you multiply with 2/3 of it, 2 by 3 times of that, whatever you have. That way I remember it. Okay. Next to go on. The center of mass of a solid hemisphere of radius 8 centimeters. That is also direct formula. I remember it this way. Whenever you have a thin, right, uniform thin spherical shell, if you have, okay, spherical shell, then it is going to be R by 2 from center. So you just compress the thin spherical shell, you'll get actually uniform dot there. So that is a very simple idea. You need to remember. I can remember it very easily. Whenever I know for a thin spherical shell, right? When you go for solid sphere, when you go to, then the answer becomes 3/4 of it, 75%. 3/4 of R by 2. That's why I remember. It works even for solid cone also. All right. So this is going to be 3R by 8. Okay. And R they gave 8. That means here it is going to be 3 centimeters. All right. That's what the answer is. So that's, I think, the questions here. With that, I'll conclude here. So I hope that you got most of the models that are used in system of particles. I'll come with one more set of questions, probably around 20. If you go through all those questions, that is enough. In system of particles, all the ideas that are asked in JEE mains mostly will be covered. So I'll conclude here. Thank you very much for joining. Until next time, bye.